Hello, everyone. Today I will introduce our paper, Static Analysis of Resource Usage Bounds for Imperative Programs. This paper is about how to derive resource usage bounds for imperative programs. I will use the following 5 parts to introduce: introduction, existing work, our approach, implementation, experiments, and conclusion. Introduction. In order to derive resource usage bounds, we first look at resource. In C programs, there are various resources, including heap memory, file descriptors, sockets, and user-defined resources, etc. Resource usage bounds can provide guidance for software design, configuration, and deployment. They can also detect software bugs, such as CWE 400 and CWE 769. They are all relevant to resource usage bounds. Secondly, existing work. From SPID to C4B, most of them focused on deriving loop bounds of numerical programs, which is different from resource usage bounds. They also do not consider pointers. Among them, although C4B considers resource usage bounds, it cannot automatically inform the resource size change for resource manipulating APIs. This challenges us in deriving resource usage bounds. Thirdly, to meet the challenge, we leverage our approach, which we call static analysis of resource usage bounds. In this page, the figure shows the workflow of it. The workflow can be divided into 3 steps. Step 1, from original program or resource usage modeling program, we checked resource usage by program transformation. Then step 2, we reduce program scale by program slicing and get sliced program. In the final, step 3, we use static analysis based on abstract interpretation to derive resource usage invariance. From now on, we illustrate our approach via an example step by step. Step 1, program transformation, helps to derive resource usage modeling programs. We firstly introduce auxiliary integer variables to model the resource usage. In our example, for resource JAS, we use resource JAS color and resource JAS peak to respectively check the current amount and the historical peak amount of its usage. Secondly, we instrument auxiliary statements that update the value of resource usage modeling variables according to the semantic of that function. In our example, these statements are line 9 and line 10, which we color green. Step 2, program optimization. We reduce program scale by program slicing when only concerning resource usage. We do this optimization based on the insight that many variables and statements in the program are not relevant to resource usage, so we can conduct program slicing over the resource usage modeling program. You can see in our example, this one is irrelevant variables, and this one is irrelevant statements. So, in our example, the variables and statements colored green are removed by program slicing, which makes the program slimmer, and then we get the sliced program. Step 3, static analysis based on abstract interpretation. We use static analysis techniques to analyze the sliced program. The main idea is to conduct resource-bound analysis by combining numerical value analysis and pointer analysis under the unified framework of abstract interpretation. We use numerical value analysis to infer numerical relations among variables, and we use pointer analysis based on point to abstract domain to deal with resource manipulating functions involving pointers. In our example, this one should use pointer analysis, and this one should use numerical value analysis. And we can find that by static analysis, at the end of the program, in other words, the position the red 5-pointed star marked in part C, the upbound of resource JS and resource JS peak are the last line in part D. Fourthly, implementation and experiments. We implemented our approach as a tool. We used Consignia for instrumentation, and we used Pharmacy's slicing plugin for program slicing. The tool is implemented based on the float and CIL, numerical abstract domain library apron, and the fixed point solver library. The table shows the experimental setup and results. The current project shows that we have conducted our experiment on a set of programs from open source projects, Source, FastDFS, Redis, and Jasper. And the current resource type shows their corresponding type. Current line and line sliced shows the number of lines of code before and after performing slicing respectively. The current time indicates that the time overhead of our approach is also acceptable. The current peak shows the resulting upbound of peak resource usage in these programs. And lastly, conclusion. From the results, we can make the following conclusion. We give a static analysis approach to deriving resource usage bounds for imperative programs, while program transformation, program slicing, numerical value analysis, and pointer analysis. Experimental results shows that the ability of our approach to infer the usage bounds of various types of resources in real-world programs. That's all my introduction. Thank you for your listening.